In 4 years, the largest coral reef restoration project on Earth took a dead reef in Indonesia from 2% coral cover to 82%. Fish populations at the same site increased by 925%. Sharks returned to waters that had been silent for a decade. This happened at Hope Reef in Sulawesi, and it happened because of 60,000 steel hexagons placed on the seabed by hand. The Mars-assisted reef restoration system, Mars, is the largest coral restoration program on the planet. As of 2025, it operates across 124 active sites in 17 countries. The 2025 impact report documented 225,000 corals outplanted in a single year. Rewilding is not always about letting nature take over. Sometimes nature needs a scaffold first. What killed Hope Reef? And what is killing reefs everywhere? The reef sits at the heart of the world's coral triangle in the Permas archipelago, off the coast of Sulawesi near Bontosua Island. For decades, destructive blast fishing turned the seabed into a field of loose rubble. Coral cover across the island dropped to 5%. In the waters once silenced by dynamite, almost nothing lived. The threat is not unique to Sulawesi. Scientists estimate that 90% of the world's tropical reefs will be gone by 2043 if current trends continue. Two forces are driving this collapse. The first is coral bleaching. When ocean temperatures rise, corals expel their zooxanthellae, the tiny symbiotic algae that live inside coral tissue, the microscopic algae that live inside coral cells and supply up to 90% of the coral's energy through photosynthesis. A bleached coral is a starving coral. If the heat persists, it dies. The National Oceanic and Atmospheric Administration confirmed in 2024 that the world entered its fourth global mass bleaching event on record. The second force is ocean acidification. As carbon dioxide dissolves into seawater, it lowers the ocean's pH, making it chemically harder for coral to calcify, to build the calcium carbonate skeleton that forms the reef structure itself. Dr. Ines Lang from the University of Exeter, who studies carbonate accretion rates at Hope Reef, has documented this directly. A reef that cannot calcify faster than it erodes disappears. That is the trajectory most reefs are currently on. Hope Reef was a test of whether large-scale restoration could interrupt that trajectory at all. What is a reef star, and how does Mars work? A hexagonal steel structure called a reef star became the answer. Each reef star is approximately 3 feet wide, made of sand-coated steel, and designed to interlock with its neighbors. The hexagonal shape is deliberate. Permas Bagya Maulana, the lead scientist at Mars Symbioscience Indonesia, explained in the 2025 Mars Impact Report that the hexagonal design makes it easier to interlock the structures, allowing them to stabilize rubble areas. When the legs of each star touch those around it, they form a strong, interconnected web across the seabed. The reef stars are not factory-produced. Local community members from Bontosua and Badi Islands make them by hand, coating each one with sand to give Acropora and other coral fragments a textured surface to grip. Acropora, the staghorn and tabletop corals that form the branching architecture of healthy tropical reefs, are among the fastest-growing coral genera and the primary species used in restoration. Divers carry the stars down and place them on the rubble. In a single day, a team can install enough reef stars to cover a basketball court. After installation, the project follows a strict coral gardening schedule, the formal marine science term for active, ongoing reef stewardship. Checks occur at weeks 2, 4, 8, and 12. Divers replace dead coral fragments, remove algae with brushes, and record mortality data. Coral gardening distinguishes this method from passive reef protection. It is not a one-time planting. The fragments being transplanted are not selected randomly. The project specifically chooses colonies that retain their zooxanthellae during past heat events, corals that demonstrated measurable heat tolerance when water temperatures spiked. Climate adaptation is built into the selection process from day one. What did the data actually show? The data from Hope Reef is unlike anything previously documented in marine restoration science. At the flagship installation, coral cover started at 2% in 2017. By 2021, it had reached 82%. Across the island of Bontosua as a whole, coral cover climbed from 5% to over 70% across the same period. Fish populations at the Hope Reef site increased by 925%. The number of fish species rose by 58%. Sharks and sea turtles returned. The Napoleon wrasse was sighted again within the formally designated marine protected area surrounding the site. MPA status legally controls fishing pressure in the surrounding waters. A restored reef without MPA protection is a reef that can be blast fished again. The combination of active restoration inside a protected zone drove these results. Most significantly, the restored corals began spawning naturally. Once a year, healthy coral colonies release bundles of eggs and sperm simultaneously into the water column, a mass spawning event timed to the lunar cycle. When restored corals spawn, it confirms the reef has crossed from survival into reproduction. It also means the carbonate accretion rate, the rate at which the reef builds new calcium carbonate skeleton, now exceeds the erosion rate. The presence of crustose coralline algae, which acts as natural reef cement, further stabilizes this growing structure. The reef is not holding on, it is growing. Permas Bagya Maulana stated in the impact report, "Before the restoration, sharks were almost never seen. Now, they have come back." Why do most coral restoration projects fail, and what does Mars do differently? The Reef Star technology solves the problem that kills most coral restoration projects: rubble stabilization. On a degraded reef, loose coral rubble shifts with every wave and current. New coral fragments cannot settle because the ground moves beneath them. The Reef Stars tie the seabed together, creating a stable platform where coral can attach and grow. The hexagonal interlocking is the mechanism. Each star supports its neighbors. The whole structure acts like a net holding the rubble in place. Within a few years, coral completely overgrows and engulfs the steel. The Reef Stars disappear beneath living tissue. They are temporary scaffolding, not permanent fixtures. Nature takes over exactly as intended. This is the engineering principle that separates Mars from coral nursery methods. It solves the substrate problem first, then the biology follows. How are researchers measuring whether the recovery is real? A team of independent scientists has been studying Hope Reef using methods that go beyond visual surveys. Rinda Vida, a graduate student at IPB University in Bogor, Indonesia, uses photogrammetry, collecting thousands of underwater images and building digital three-dimensional models of the reef. These models quantify the structural complexity of the habitat, which is essential for providing shelter for diverse species and breaking wave energy during storm events. Ben Williams, a PhD student from University College London, pioneered the use of artificial intelligence to track reef recovery through underwater acoustics. Healthy reefs are loud at night. Fish, invertebrates, and snapping shrimp generate constant acoustic activity in a functioning ecosystem. The 2025 Mars Impact Report confirmed that AI-powered acoustic monitoring found restored reefs are growing louder at night, a measurable sign that healthy ecosystems are attracting juvenile fish and invertebrates back to the site. Dr. Inez Lang from the University of Exeter applies reef budget analysis, a peer-reviewed methodology for calculating carbonate accretion and erosion balance, determining at the structural level whether a reef is building or collapsing. Reef budget methodology also accounts for bioerosion from parrotfish grazing, the natural process that breaks down coral skeleton. Adib Mustafa, a PhD student at the University of Southern California, studies the genetic diversity of restored coral communities to determine whether species composition matches naturally healthy reference sites. Professor Nick Graham from Lancaster University documents the behavioral dynamics of fish populations on healthy versus restored reefs. Before any reef stars enter the water, the Mars method requires 3 months of baseline data collection. This includes water temperature, habitat structure assessment, coral community surveys using the AI platform CoralNet, fish community surveys recorded with the Mermaid app, and coral disease screening. The majority of reef restoration projects worldwide do not collect pre-restoration baseline data at this level of rigor. This is why the Hope Reef results are credible in the peer-reviewed literature. Where has Mars been deployed, and what new threats is it encountering? Hope Reef was designed as a proof of concept that could scale globally. As of 2025, the program operates across 124 active restoration sites in 17 countries. In 2025 alone, more than 15,000 reef stars were installed, and 225,000 corals were outplanted across 28 new sites. In March of 2025, the first Colombian coral reef restoration program using Mars Reef Stars was completed at Varadero Reef in Cartagena Bay. 100 reef stars were installed, outplanting approximately 1,500 coral fragments. Local Colombian volunteers responded to a public call and contributed directly to the build. The Corrales de Paz team received full training in Reef Star fabrication and installation during the same week. Also in 2025, Indonesia completed its first all-women reef builder training program. The Mars program now operates in Indonesia, Hawaii, the Maldives, Australia, Kenya, Malaysia, and Colombia. Mars Incorporated has invested more than $10 million in research, restoration, and community engagement since the program began in 2008. In the Atlantic, the program faces a threat that does not exist in the Indo-Pacific. Stony coral tissue loss disease, SCTLD, has been devastating Caribbean reefs since it was first documented off Miami, Florida in 2014. NOAA has tracked its spread to over 30 countries and territories. SCTLD kills coral tissue up to 24 times faster than other known coral diseases, unlike white band disease, which devastated Caribbean Acropora in the 1980s. SCTLD attacks a broader range of species. Unlike bleaching, which is triggered by heat stress, SCTLD is caused by a bacterial or viral pathogen that attacks living coral tissue directly. Mars teams working in the Caribbean now select coral fragments based on demonstrated SCTLD resistance alongside heat tolerance. The science of restoration is evolving to meet threats that did not exist when Hope Reef was first designed. Why does this story belong to Rewilded? Most coral restoration videos show divers planting coral fragments and stop there. What makes the Mars method a Rewilded story is the philosophy behind the engineering. The reef stars are designed to disappear. After a few years, coral completely overgrows them. The steel becomes part of the living reef. The scaffold dissolves into the biology. The goal from the first day of installation is to make the intervention invisible. Hope Reef spells the word HOPE in letters 14 meters wide and 46 meters long on the seabed. The installation is visible on Google Earth from space. That is not decoration. It is a demonstration, visible to satellite, that active, large-scale restoration works when it is built on rigorous data, consistent maintenance, and genuine community involvement. The reef is no longer dead. It is not just surviving, it is reproducing. What are the limits of what Hope Reef proves? Hope Reef is located in a region with naturally high temperature variability, which gives its corals a degree of heat resilience not found on every reef. The area has not experienced a severe bleaching event in over a decade. That environmental good fortune is part of the story and should not be erased from the data. The global outlook for coral reefs remains serious. 90% of the world's tropical reefs remain at risk of disappearing by 2043, according to the Intergovernmental Panel on Climate Change. Coral bleaching events are becoming more frequent and more severe as ocean surface temperatures rise. Ocean acidification continues to slow carbonate accretion rates globally, and SCTLD is spreading through Atlantic reef systems faster than any restoration program can currently match. Hope Reef does not solve those problems, but it provides the largest documented proof of concept for large-scale coral restoration anywhere on the planet, and it is still growing. In 2017, this reef was a field of rubble with 2% coral cover. Today, the same site carries 82% coral cover, a 925% increase in fish populations, and sharks in waters that had been biologically silent for years. 60,000 steel hexagons lie across that seabed. Most are already invisible beneath new coral growth. The zooxanthellae are back inside the coral cells. The carbonate accretion rate is outpacing erosion. The corals are spawning, the fish are returning, the reef is building itself. They built a scaffold. Nature took over. And from space, the letters spell HOPE. That is what rewilding with engineering looks like. It is not permanent. It is not easy, but it works.